Let's start chapter number 7, Chemical Energetics. Our key learning objectives are distinguish between physical and chemical changes, understand energy transfers in chemical reactions, analyze reactions pathway diagrams, calculate enthalpy changes, define activation energy. First, let's talk about physical versus chemical changes. Physical changes, definition, changes in physical properties or state without creating new substances. Example, state transformation, solid to liquid. No chemical composition alteration, often reversible. Now let's talk about chemical changes. The definition is processes where new substances are formed. Involves breaking and forming chemical bonds, typically irreversible. Now, let's talk about energy in reactions, exothermic and endothermic processes. Exothermic reactions characteristics are releases thermal energy to surrounding, temperature of surroundings increases, enthalpy change delta H is negative. Now, in endothermic reactions, the characteristics are it absorbs thermal energy from surrounding when it is endothermic reactions. Temperatures of surrounding decreases and enthalpy change is positive. Now let's talk about bond energy calculations. Fundamental principles. Bond breaking, which will happen in endothermic process and it requires energy. In bond formation, will be an exothermic process and it will result in release in energy. Activation energy EA definition is minimum energy required for a chemical reaction to occur. Represents energy barrier molecules must overcome. Factors influencing activation energy are temperature, catalyst, and molecular complexity. Some practical applications like refrigeration technology uses evaporation condensation cycle, heat transfer principles, environmental sustainability considerations. Now, let's talk about key terminology table. Delta H means enthalpy change and it is a type of measurement. EA is an activation energy and the type is energy barrier. Exothermic energy releasing reaction, it is a type of reaction. And endothermic reaction in energy absorbing reaction, also it's a type of reaction. Now let's talk about physical change and chemical change. Physical changes definition is changes that do not create new chemical substances. The characteristics are substances remain chemically identical, often easily reversible, can involve heat energy transfers. Some examples are water in different state, ice, snow, liquid, dissolving sugar in ethanol or water. Now let's talk about energy in physical changes. Here we have endothermic processes. It absorbs heat energy. Examples are melting and evaporation. Exothermic processes here releases heat energy and examples are condensation and freezing. Now, in chemical changes, what are chemical changes? Definition: reactions that produce new substances. Key features: formation of new chemical substances, often difficult to reverse, can involve energy release and absorption. Types of chemical reaction: exothermic reaction, it releases energy, heat in the form of heat, in the form of light. They are more common. Example: magnesium burning in oxygen. Endothermic reactions absorbs energy from surrounding. They are less common. An example are nitrogen and oxygen reactions during lightning. All right. Now, exothermic and endothermic reaction mechanism. Okay, energy transfer mechanism in these reactions. Exothermic reactions, heat exists the reaction, it exits the reaction. Temperature of the surrounding increases. Why? Because heat exits, due to which the surrounding temperature increases. Endothermic reaction, heat enters the reaction and due to which temperature of surrounding decreases. Now, bond breaking and bond making. Energy dynamics here. Bond breaking. It's an endothermic process and it requires energy input. Bond formation, it's an exothermic process and it releases energy to surroundings. Now, let's talk about enthalpy concepts. Enthalpy, donated by H. Thermal energy content of a system. Enthalpy change, represented by delta H, measured in kilojoules kJ, negative for exothermic reaction and positive for endothermic reactions. Now, example of reaction, methane combustion. Now, let's talk about key terminologies. Chemiluminescence, energy release in light form. Chemical energy, energy released or absorbed during reactions. Now, some practical applications are natural gas combustion, photosynthesis, and industrial heat generation. Now, let's talk about chemical energetics, where how reactions pathways are and how energy changes, bond breaking, and energy processes. Now, bond breaking characteristics. Nature of bond breaking. Endothermic process requires energy input to break chemical bonds, fundamental to understanding chemical reactions. Activation energy. Why activation energy is universal, essential for all chemical reactions, provides energy barrier to initiate reaction. Even low energy reaction requires some activation energy, represents the minimum energy needed to start molecular transformation. These all properties are very important for examination perspective. Hydrogen peroxide decomposition reaction. So you can see there are different bonds, single bond, double bond, and again the single bond, and different energies which are required to break the bond. Reaction characteristics determines whether reaction is exothermic or endothermic. Means if it is exothermic, energy will be released. If it is endothermic, energy will be absorbed. With this, we have finished our this chapter and see you in our next chapter.